So this is 7.3 absolute value equations. These are the following steps that we are going to take to solve an absolute value equation. You need to isolate the absolute value expression. The expression inside the absolute value could be positive or it could be negative, so we need to write a positive equation and a negative equation, solve both, check your answers, there may be extraneous roots, and write your answers in solution brackets. So the first thing that I'm going to do is I'm going to show you how we're going to solve it by graphing, and then I'm going to show you where they intersect and how that shows a solution, and then I'm going to show you how to do it algebraically. So I'm going to pause while I graph, and I'll be right back. Okay, so now we can see on our graph here that we have an intersection point about right here and about right here. I can for sure tell what this one is. It looks like if I go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, x should equal -4. And over here, it's not quite clear unless you use your slope. So if we do this, if we go, this comes over 1, 2, 3, 4, 5, 6, 7, and then we go over 1, but again, we're kind of just guessing. Like, I would say that's about x equals 9, x equals 10. It's a little hard to see because we didn't really put this graph in a good spot. So we know it's about here, and we know that there should be two solutions. So let's prove our solutions algebraically. So the way I like to set this up, and this one's really nice, it's already set up that the absolute value is isolated. So I like to say, okay, I'm going to do my positive one first, and I write out what that looks like. And then over on the right, I set up my negative one. So then it's negative x minus 3, and I'm only multiplying a negative into where the absolute value brackets are. So then this is a really easy solve over here. All we need to do is add 3. And then we get x is equal to 10. So our graph was pretty accurate. And then over here, we multiply the negative in first. You get negative x plus 3 is equal to 7. Now what I would do is I would add x to both sides and subtract 7. So then you would get that -4 is equal to x. So both of those solutions we did on the graph match, but now we need to do our check. And this subs into the original equation. So if I went the absolute value of 10 minus 3 is equal to 7, is the absolute value of 7 equal to 7? Yes, it is. So this is a good solution. So we put a circle around it because that's a fact. And then we do our check over here. And we ask ourselves, okay, is -4 minus 3 the absolute value of it equal to 7? Well, let's check, and then -4 minus 3 more gives us -7. Is the absolute value of -7 equal to 7? It is. So these are both valid solutions. So let's try a few more here. Our next one that we are going to deal with is we need to solve the absolute value of x plus 5 equaling to 4x minus 1. Again, this is really nice because it's set out already the absolute value being isolated. So we set up a positive one, and we get x plus 5 is equal to 4x minus 1. And then we'll set up our negative one, I don't know, over here, a little bit higher. And we get negative x plus 5 is equal to 4x minus 1. And you don't have to do this step. If you can do this all at once, please do it. I'm just kind of going a little bit slower so you guys can see the thought process. So then over here, we will start with the positive one. What we will do is we will get all the x's to one side, so subtract x, and add 1. And we get here that 6 is equal to 3x. So divide by 3, and we get 2 is equal to x. We'll work over here now. What I'll do is I will add x, and I will add 1. So then I get negative 4 is equal to 5x. And I divide by 5, and I get negative 4/5 is equal to x. Now I need to do my checks. So then the absolute value of 2 plus 5 is equal to 4 multiplied by 2 minus 1. So the absolute value of 7 is equal to 8 minus 1. 7 is equal to 7. This one works. Circle it. Okay, and then we do our check here. We have the absolute value of negative 4/5 plus 5 is equal to 4 multiplied negative 4/5 minus 1. So then this should be over 1 times 5 times 5. So that gives us 25 minus 4. So it gives us the absolute value of of 21. Not that it really matters, because at that step it would change over. So it's 25 plus negative 4, so 21 over 5 is equal to negative 16. 4 times 4, 4, 8, 12, 16, yeah, over 5 minus 5 over 5. So this gives us 21/5 is equal to negative 21 over 5. So this is not valid, so this is extraneous. And it's very common. What we do is we just scratch them out. Next one. This one, finally, we have one where we need to isolate. Good thing it's an easy isolate. We just move them over. So then our equation really is 4x minus 5 is equal to negative 7. Let's do our positive over here. So we get 4x minus 5 is equal to negative 7. We will add 5. And we get 4x is equal to negative 2 divided by 4. X is equal to negative 1/2. And then I'm going to do my check. So then is the absolute value of 4 multiplied negative 1/2 minus 5 equal to negative 7. This is the absolute value of negative 2 minus 5 equals to negative 7. The absolute value of negative 7 equaling negative 7. 7 does not equal negative 7. So this guy is extraneous. Next one. Let's do our negative. So then that gives us negative 4x plus 5 is equal to negative 7. So what I'm going to do here is I will add 4x and I will add 7. So then that'll give us 12 is equal to 4x. Divide by 4. 3 is equal to x. Then we will do our check. So then that gives us the absolute value of 4 times 3 minus 5 equaling to negative 7. And you get 12 minus 5 equaling to negative 7. And we get 7 does not equal negative 7. So both of these solutions are actually extraneous. Okay, our next one we can see is that we are dealing with a quadratic. Nothing changes. We still have a positive and a negative version of it. So our positive is equal to x squared minus 2x equals to 1. So then x squared minus 2x minus 1 equals 0. Then what we need to do is we need to solve this. And we can see that we're going to have to use our quadratic equation. So you go through and use the quadratic equation, and you will find that x is equal to 1 plus or minus the square root of 2. Then you'll need to check it. So you would plug this in using your decimal value or your complete value if you could, and you will find that this is a valid solution. I'm not writing it down because you should know how to sub this in. It would be very simple. I'm just going to do like the first bit. So this you would have to check both of them. So you had a 1 plus or minus 2 squared minus 2 bracket 1 plus root 2 minus 1 equals 0. And then you would have 1 minus root 2 squared minus 2, 1 minus root 2 minus 1 equals 0. Both of these work. Case 2, our negative case, we have negative x squared plus 2x is equal to 1. So then this becomes x squared minus 2x plus 1 equals 0. This is a perfect square trinomial, so this is x minus 1 squared is equal to 0. So x equals 1. And then we check. And this would just be 1 squared minus 2 minus 1 equals 0. Am I doing that right? Yeah, so then that would be, wait a second. So then this would be better off doing it this way. So if we sub it into the original, we have to sub it into the original absolute value. That's my bad. So then this should have absolute value brackets here, and this should be plus 1 here. No worries, easy fix. So then 1 squared minus 2 equaling to 1, and this works as well. So then you would have your solution set, and you could also verify this graphically if you would like, but I prefer algebraically. Last one. This one, again, it's already isolated, so we don't have to do much with that, but we have our positive version, where we have x minus 10 is equal to x squared minus 10x. We will add 10 and subtract x. That gives us x squared minus 11x plus 10 equaling to 0. So that gives us a solution set of x minus 10. Once we factor it, x minus 1, x equals 10, x equals 1. So we plug this into the original, the absolute value of 10 minus 10 equaling to 10 squared minus 10 multiplied by 10. So that's 0 equals 0. This one works. And then if we plug it into the first one using 1, so circle this one because we know it works. This would be the absolute value of 1 minus 10 is equal to 1 squared minus 10. So then negative 9 is equal to negative 9. Oh, sorry, that's the absolute value of negative 9 is equal to negative 9. So 9 is equal to negative 9. This one does not work. Okay, let's do our negative case. So this becomes negative x plus 10 is equal to x squared minus 10x. And I want to draw attention to the fact that this is the only one, again, that got negative, not this one. So then what we're going to do here is we need to add x and subtract 10x. Sorry, not 10x, just 10. Okay, so then that leaves us with x squared minus 9x minus 10 equals to 0. So then we get our solutions of x is equal to 10, minus 10, sorry. I should just factor it. Let's go a little bit slower. So then we get x minus 10 multiplied by x plus 1 equals 0. So x equals 10, x equals negative 1. So we know that this one already works, so we don't have to test him, but we need to test our negative 1 here. So then the absolute value of negative 1 minus 10 is equal to negative 1 squared minus 10 multiplied by negative 1. This gives us the absolute value of negative 11 is equal to 1 minus plus 10. So then this gives us 11 is equal to 11. So this guy is also a solution. So our solution set would be x is equal to, so we go brackets, 10 and negative 1. All right, you are off onto the assignment.